On question number 1, we were given a point and asked if it was a solution to the system of equations. On these questions, we're going to be given a system of equations, but we have to find what that point is. And there's actually 3 different methods for doing this. We have the substitution method, we have the elimination, or sometimes it's called the addition method, and then we have the graphing method. Now the substitution and the elimination method, these are both algebraic methods. The graphing method, we're just going to be graphing the lines and then finding the intersection point. And we're actually going to be using the calculator on this. So here are the steps for the substitution method, and I'll talk about these steps as we go through question number 2. Before we do number 2, I want to rewrite it with different colors because I think that can help sometimes with the substitution method, but you don't have to if you don't want to. Okay, so step number 1 says to isolate one of the 4 variables, and this may already be done. So what that means is we have the top x, the bottom x, the top y, and the bottom y. And one of these variables has to be by itself on one of the sides of one of the equations. And that is not done here. So we need to isolate one of these 4 variables. And I'm actually going to choose to isolate the bottom x because it doesn't have any number in front of it. So all the other 3 variables all have coefficients in front of them, which means that at some point you would have to divide by those numbers. So that would just make it more work. So I'm going to isolate for the bottom x, which means I need to subtract 3y from both sides. And x is equal to 2 minus 3y. The second step, we want to substitute the expression from step 1 into the other equation. So I'm taking this equation and I want to plug it into the other equation, and I want to plug it in where the x is. So I isolated for x here with the green equation, so I need to plug it in for x in the blue equation. So I need to copy the blue equation, and instead of putting an x here, I'm going to put a open parentheses. So if you look, I really just have the blue equation here, except for I have a open parentheses instead of the x. And this is because I'm plugging in that green equation in for x. So 2 minus 3y. So now you have an equation with one variable. Solve this equation. So if you look at this, I have green y's and blue y's, but I only have y's, so there's no x's here. So this is something that I can solve. So I'm going to distribute. That will give me 14 minus 21y minus 3y is equal to negative 10. Then I want to combine like terms. So negative 21y minus 3y is negative 24y. Then I want to subtract 14 from both sides. And then finally divide both sides by negative 24. And we get y is equal to 1. So we have what y is equal to. Now we need to find our x value, and that is the last step here. So substitute the value found in step 3 into the equation from step 1 and solve for the other variable. So I'm plugging in y is equal to 1 into y here so that I can solve for x. And I'm kind of running out of space. So x is equal to 2 minus 3y, but I know y is equal to 1. So if I solve that, x is equal to 2 minus 3, which is negative 1. So x is negative 1, y is positive 1. So my final answer would be negative 1, comma 1. So this is the point that works in both of these equations. So if you wanted to check your work, you could plug it into both of those equations, and it would work.